All right, good afternoon. We're going to get started. I'm Dr. Kay Stefanik, Assistant Drafter of the Iowa Nutrient Research Center. Those of you online, if you have questions for either speaker, please type them into the chat box to me, or wait until we get to the question and answer session and you can unmute yourself and ask your question then. So our first speaker today is Dr. Lindsey Hartfiel. She is the Research Program Manager at Discovery Farms with University of Wisconsin-Madison Extension. Dr. Hartfiel will be speaking about on-farm water quality monitoring in Iowa and Wisconsin.
All right, thanks, Kay, for that introduction. I will go ahead and get started right away in this presentation. So before getting into the details of the presentation, I will give an outline here of kind of what to expect as I move through the presentation. So I'll start with a little introduction, a little bit about my background and a little bit about me. But then I was asked to highlight a little bit of my work while I was at Iowa State, how the Iowa Nutrient Research Center kind of helped me to get to where I am today, and also then just a little bit of highlight of my current role as well. So a little bit about my background. I am originally from Wisconsin, grew up on a small dairy farm in Wisconsin, and so I attended the University of Wisconsin River Falls for my bachelor's degree in agricultural engineering. And I graduated in 2019 from there. And right away I started with Iowa State University then for my PhD in Ag and Biosystems engineering. And I graduated last December, so not quite a year ago. And since graduating then, like Kay said, I am with the Discovery Farms program with UW-Madison Division of Extension, which I'll highlight a little bit more at the end. So then just a little bit more about me. Like I said, grew up on my family's dairy farm, but my husband also grew up on his family's farm in Wisconsin. So during our free time, most weekends, you can find us on one of our family farms helping out. So with that, I'll move into discussing a little bit of the ISU research that I did. But before getting into that, I'll give a little bit of an overview of what the research was about. So this study focused on denitrification bioreactors. So for anyone who is maybe not as familiar with what a bioreactor is, I'll give a quick overview of that, of what they are. So I'm sure everyone tuning in is familiar with Iowa and the tile-drained landscape that is much of Iowa. So with that tile drainage, obviously there's a lot of benefits. You can get in the field sooner, improve those crop growing conditions, and as a result get better yields, especially in those wet areas. But as again, I'm sure a lot of you are aware, the nitrate within that soil can also be easily transported in that tile drainage. And so we have some environmental and human health concerns with all that nitrate in our leaving those tile drainage systems to our surface waters, which is where the denitrification bioreactor comes into play. These bioreactors, you can consider it as underground trench filled with some kind of carbon source. In this image, it's wood chips. That's the most common one. But that trench is set up to intercept that tile drainage and to facilitate what we call microbial denitrification, which is the conversion of the nitrate coming in to an end product of nitrogen gas, which is a harmless end product, makes up the majority of our atmosphere. So how do we go from the nitrate to the nitrogen gas? In that bioreactor, there's bacteria that work to convert the nitrate to nitrogen gas. And those bacteria are naturally present in our environment already. So as a microbial process, the longer the water can be in that bioreactor for, the more time they have to convert that nitrogen to nitrogen gas. That'll be a factor as I go through these slides to remember. So now moving into the specifics of the part of the research I did while at Iowa State. I'm going to highlight the results from a study at what we call a dual chamber bioreactor. And as a dual chamber bioreactor, you can think of this as two bioreactors that are connected in parallel. So this one, then its configuration is a little bit unique compared to most bioreactors. So I'll draw your attention to the first blue box at the bottom of the screen there, what we call the main inlet. This is a water control structure that is used to either direct the flow into the bioreactor, or if there's enough water flowing, if there's too much more than the bioreactor can handle, then it allows for the water to bypass there. Otherwise, the water is directed into what we called inlet A and inlet B. These are two smaller inlet water control structures. And those inlet control structures are all there to kind of help set how long that water isn't going to be in that bioreactor for, set that hydraulic gradient going through the bioreactor. So from there, the water flows through the two chambers that we call chamber A and chamber B, and it'll eventually end up at the two outlet water control structures that we called outlet A and outlet B. Also part of the bioreactor were 9 randomly located sampling wells, and those are there just for research purposes, so we could see what was going on inside that bioreactor for the purpose of our research. So normally we wouldn't have these sampling wells. In terms of our monitoring, we started monitoring these bioreactor chambers in 2019, and we started monitoring for nitrate, total organic carbon, water level, temperature, dissolved oxygen, and flow rate. For today's presentation, I'm going to start by focusing in on the nitrate and the flow rate results. But I also want to highlight that a lot of the visuals you'll see moving forward were generated using what's called inverse distance weighting, a statistical approach to interpolate those concentrations from those water control structures and our sampling wells to get the concentrations of the different things we're monitoring across the length and width of the bioreactor. So the first thing I'll highlight is the flow rate. Like I said, we started monitoring in 2019, but for the purpose of making things easy to see on the slide, I just have the flow rates from 2020 and 2021 here. But the main thing is that the story was pretty consistent over time, and that we were consistently seeing low flow rates in the bioreactor. So I'll draw your attention to the blue line at the top of the graphs, and that's the flow rate that each bioreactor chamber was designed to treat. And then next, I'll draw your attention to the yellow and gray lines, which are the flow rates leaving chambers A and B respectively. So you'll notice that that design flow rate wasn't ever actually reached in either bioreactor chamber. And most of the time, those flow rates were well below what the bioreactor was originally designed for. So what does that mean in terms of how that bioreactor would perform? With those low flow rates, that means that water would then be in that bioreactor for a long amount of time. That gives the bacteria a lot of time to work to convert the nitrate to nitrogen gas. So then when we look at, now we'll look at the nitrate removal. So to orient you with the figures, at the bottom of the screen, this is the inlet of the bioreactor, and the outlet's at the top of the screen. And then these are representing the median concentrations we saw over time. So 2019 on the left to 2021 on the right. And then also with the colors here, the lighter colors, the yellows, the greens, those are the higher nitrate concentrations. And then as you get to blues and purples, those are low nitrate concentrations. So starting on the left with 2019, you can see we started with high nitrate coming into the bioreactor at the inlet, but pretty early on, by about that 10-meter mark in terms of the bioreactor's length, all that nitrate was essentially removed. Looking at 2020, you can see again, it took a little bit longer for us to get to that point of complete nitrate removal, but by about that 30-meter length in the bioreactor, we had reached that complete removal. And again, looking at 2021, looks pretty similar to 2019. By that 10-meter mark, all that nitrate had been removed. In the interest of time, I'm not going to show chamber B, but 2019 to 2024 chamber B looked very similar to chamber A. So based on the results we saw for 2019 and 2020 for both of those chambers, we decided to add some additional monitoring in. And the first thing we added monitoring in for was sulfate. With the sulfate, the reason we added this monitoring in is because once all that nitrate's gone, those bacteria will look for something else to be reducing in the bioreactor. And so one of the next things they'll look to reduce is sulfate. And so that's something we don't want to be seeing happening in the bioreactor, is seeing sulfate reduction happening. So there's two reasons we don't want to see the sulfate reduction happening. The first being that means our carbon source, our wood chips in this case, were being used for something other than what we intended them to be used for. And the second, more concerning one, is that when in other freshwater systems, sulfate reduction has been linked to methyl mercury production, which is another water quality concern. So this means there's the potential that we're trading our original water quality problem for a different one. Then we also added in monitoring for dissolved greenhouse gases. We added in monitoring for nitrous oxide. That one's an intermediate step in the denitrification process, so that's why we included that one. And then we also included monitoring for methane. Similar to sulfate, once all that nitrate's gone, we can see methane being produced in these bioreactors as well. So now I'm showing the median concentrations for all those different things that we were monitoring for in chamber A in 2021. Again, inlet at the bottom of the screen, outlet at the top. Lighter colors are high concentrations, darker colors are low concentrations. And I'll start on the left with the nitrous oxide. So this, when we look at the nitrous oxide, it went from a higher concentration to a lower concentration. So we were happy with that result. That means we weren't producing nitrous oxide, which is a greenhouse gas. It actually was reduced. That was a good observation to see. Looking at the nitrate, this time, give it a little bit of a mixed feelings face. It's great that nitrate was being removed in the bioreactor, but we don't want to get to a point of complete nitrate removal, which we saw in chamber A. So the reason we don't want to get to that complete nitrate removal, now when we look at the sulfate, you can see the colors have changed. It went from a high concentration to a lower concentration. So we were seeing sulfate reduction happening. And again, that's linked to methyl mercury production, so potential that we're trading that original water quality problem for another one. And then when we look at methane, this time we went from a low concentration to a high concentration. So we were producing methane. So another observation we didn't want to be seen by producing a greenhouse gas. And then if you look at these in comparison to one another, especially if you focus in around that 10-meter mark in the bioreactor's length, you can see that at that point where all that nitrate has been removed, that's where we start to see the colors change for sulfate and for methane. Now we'll look at chamber B, and I will start by saying that chamber B in 2021, it had a little bit more flow going into it than chamber A. And the reason being that chamber B, when it was installed, it ended up at a slightly lower elevation than chamber A, so it tended to get a bit more flow going towards it, especially when we had lower flows to begin with. So starting on the left with the nitrous oxide again, this time I'll give it a mixed feelings face. There's a slight increase in the nitrous oxide leaving the bioreactor, but overall it's pretty consistent color throughout the bioreactor's length and not much of a change. So it wasn't too alarming, but ideally it would have been the same or lower leaving the bioreactor. Then looking at the nitrate, this time we were really happy with what we were seeing. Again, a lot of nitrate removed. But we didn't get to the point of complete nitrate removal. And the concentration at the L of the bioreactor was right around 2 milligrams of nitrogen per liter. And then looking at the sulfate now, there's not really a change in the sulfate concentrations, and the same is true with the methane. So we were able to see that keeping a higher nitrate concentration of around 2 milligrams of nitrogen per liter, that limited the potential for that pollution swapping to occur. So then one last thing we kind of wanted to think about with this was how can we manage the bioreactors to also limit that pollution swapping other than maintaining a certain concentration of nitrate. So this is what we call hydraulic residence time. And it's really, you can just think of it as the length of time that water would be in the bioreactor for. So here showing the red dashed line represents a residence time of 50 hours. And I'll zoom into these. So starting with nitrate, these are the outlet concentrations leaving the bioreactor. So we can see up to that 50-hour, that red dashed line, there's a pretty linear decline in the nitrate concentrations. And after that, then it kind of levels off that all that nitrate has been removed. Looking at the sulfate, these concentrations, they were pretty consistent throughout the bioreactor's length for residence times less than 50 hours, and they started to decrease once we got past that 50-hour mark. And then when we look at the methane, we can see low methane concentrations, less than 50 hours. And once we got beyond that point, then the methane started to increase. So the main takeaways from this work were that maintaining a target nitrate concentration of 2 milligrams of nitrogen per liter could limit the pollution swapping, as well as residence times of less than 50 hours. I didn't get to talk about, in the interest of time, everything that we included in this study, but the paper is published. And so if people are interested or want to get into more of the details, they can find this paper online and get more of that information. So next, I wanted to highlight how the Iowa Nutrient Research Center kind of helped me to get to where I am now. And so I would just say overall that the Iowa Nutrient Research Center was always very supportive of the research I was doing. But I think the most unique or like most helpful thing that I got through working with the Iowa Nutrient Research Center was the professional development opportunities. During my time at Iowa State University, I had the opportunity to help with or lead numerous different like field day events to a lot of different audiences. These range from, our typical farmer audience for a field day, but we also had ones for teachers, business owners, legislators, as well as like just other researchers as well. And so this gave me the opportunity to practice my science communication skills for a lot of different audiences and to practice how to talk about my research to just a lot of different audiences. And with my current role, in the Division of Extension, obviously outreach is a big component of that. So the opportunities I had through the Iowa Nutrient Research Center were really, really great in helping me to prepare for this current role. So in my current role, with Discovery Farms program in Wisconsin. And so what this program is we work with farmers across the state of Wisconsin to put research in on their farms to monitor if they add a conservation practice, what's the impact on water quality. And in some cases, it's just monitoring water quality in different agricultural systems across the state to get an idea of what kind of water quality we're seeing in those regions as well. But as the research program manager, my role is kind of overseeing all the projects we have going on, as well as identifying new projects and new areas of the state for us to monitor as well. So right now, we have two types of projects that we have going on. The first one, the blue sites, are what we call our edge of field sites. And then the green ones are what we call our nitrogen leaching sites. So here on this slide, I'm showing a little bit of what that monitoring looks like. So on the left is our edge of field monitoring setup. This is edge of field surface runoff monitoring. And we do this through partnership with USGS. But at the core, the monitoring setup, it's a flume that's set up to intercept a concentrated flow path at the edge of a field or a pasture, where once there's runoff, then it will trigger samples to be collected. There's a refrigerated ISCO located in what we call our gauge house. There's cameras, and it's configured so that everything can be accessed remotely. So you can look at it any time of day, see if there's samples being collected and whatnot. Then our nitrogen leaching study is what's the setup on the right-hand side of the screen. And these are done using pan lysimeters that are buried about 3 to 4 feet below the surface of the soil. And they're set up that way to intercept the water that's flowing to groundwater below that crop root zone. So there's certain areas of the state in Wisconsin that have a lot of nitrate concerns in their groundwater. And so that's kind of the areas of the state we're monitoring with these nitrogen leaching studies. And so these ones are always set up as a control and treatment study where we'll add some kind of nitrogen management tool to the field and see how that works to reduce nitrate leaching as well. So with that, I think I'm close to the end of my time. So I'll have my information there. If there's time for questions, I can answer some questions or answer them at the end or in the chat. But I also want to thank and acknowledge all those individuals listed on the slide for all their help throughout my research at Iowa State for the funding. And again, thank you to the Iowa Nutrient Research Center for the opportunity to be here today as part of the seminar series presenting and for the opportunities I had while at Iowa State as a grad student.
Okay, thank you so much, Lindsey. So we do have time for a couple questions. If you're online, feel free to either type them in the chat box or you can unmute. While we're waiting for any online questions, are there any questions from people in the audience today?
Just a quick question. I think she said, and I missed it. How many monitoring wells were within the bioreactors?
There were 9 in each of those bioreactor chambers.
So Lindsey, you mentioned 50 hours. Less than 50 hours seems to be pretty good to prevent that pollution swapping. Do you have any recommendations on maybe modifications that could have been made to that particular site to help keep that hydraulic residence time within that less than 50-hour time range?
Yeah, so there's, I think, a few things that kind of went into why that site had those like lower than expected flow rates. But since that site had been installed, the design standard through NRCS had been updated. And so now in the NRCS design standard, it does have a recommendation of 48 hours to limit that pollution swapping happening. And so for them to do that, they now have a little orifice at the outlet water control structure that's supposed to drain the bioreactor within a 48-hour period. So this research kind of reaffirms that that's a good target number to keep.
Doesn't look like we have any questions in the chat. Any final questions from the room? No? Okay, then we will move on to our next speaker. All right, so our next speaker is Jingyi Tong. She is a graduate research assistant in agricultural economics working on her PhD. She is going to be presenting on Landowners Matter Too.
Good afternoon, everyone. So I'm Jingyi Tong, a fourth-year PhD student from the Department of Economics. And today I'm going to talk about the conservation adoption of various in-field and agile field conservation practices in Iowa. It is illustrated by a state representative survey in Iowa. And I would also like to thank Chad and Malcolm for offering this opportunity for me to present here. So just a brief introduction about myself. So I'm majoring in agriculture economics, and I got my bachelor's degree from China Agricultural University and a master's degree from the University of Wisconsin-Madison. And then I worked as a graduate research assistant for the Iowa Farmland Ownership and Tenure Project, and I analyzed the results of the survey, of the 2022 survey in the summer. And the full report was released at this link. And besides this research project, I'm also interested in the women farmland ownership and regarding leasing, conservation, and transition. And since women and men, like landowners in Iowa, has like there are like a fair number, like a half-to-half percentages of men and women landowners in Iowa, actually, but the voices of women landowners has been overlooked like during the years. So there is a significant need for the extension and outreach to empower women landowners with the conservation and also management practices knowledge, and to involve them more into the conservation and these activities. So that's why I'm interested in this, and also the policy briefs and the working paper are listed here. And I also have other research chapters of my dissertation about the impact of shifting ownership structure on the adoptions of no-till and cover crops, and also the impact of land use, specifically crop rotations versus continuous corn on the environmental outcomes. So next, I'm gonna introduce the Iowa Farmland Tenure Ownership and Tenure Survey. So this is the first and only consistent data collection of farmland ownership and tenure in the US. So it has a long history from 1949 to 2022. And it was mandated by Iowa Code since 1989. And it has been conducted every 5 years. So the professionals from CSSM, conducted the telephone survey, and they allow they also allow some owners answer online too. And also importantly, it is a statistically representative survey of all owners and all land in Iowa, using the sample weights of owner and land acres respectively. And so we started asking questions about the conservation from 2017. So we have the conservation information in 2017 and 2022, and we can compare the results across the years. And about the detailed sampling design and size, and also the response rate, you can check the appendix of the full report I mentioned here. And so in total, we have 359 landowners who completed the surveys, and they represent over 200,000 landowners and about 30 million acres in Iowa. So next, I'm going to talk about survey results on conservation adoption. So this table describes the conservation practice adoption in 2017 and 2022 for several infields and agile fields practices. And it reports both the share of owners and the farmland acres that adopting these practices. And we can see that for the no-till, it has a relatively large increase, like from 21% of owners and 27% of acres adopting the practice to 26% of owners and 30% of acres in 2022. And there is also a slightly increase in the cover crops adoption, like from 2017, about 4 or 5% to 7% in 2022. And we also, so the buffer strips, the adoption of buffer strips like doesn't really change much. And we also asked some questions about the agile fields practices like saturated buffers, bioreactor, constructed wetland and also grass waterways, and also the infill practice reduced tillage. And we can see that for the saturated buffers, bioreactor, and wetland, they are like the adoption rate are pretty much low, like statewide. But the reduced tillage and grass waterways are relatively welcome. So when we look at the spatial heterogeneity of no-till adoption, like across counties, we can see that the southwest and southeast, they relatively have a higher share percentage of adoption of no-till. And this can be partially explained by the higher share of the erodible land in these districts. So the upright corner is the scatter plot showing the positive correlation between the county level share of farm acres adopted by no-till and also the county level land erodibility factor. So for cover crops across counties, we can see that the northeast and northwest regions have a relatively higher adoption rate. And this can be related to the higher share of livestock, like farms raising the livestock in these districts, as cover crops can be a feed for their livestock. And also the scatter plot shows a positive correlation between the county level share of farm owners adopting cover crops and also the county level of share of owners with livestock. So when we separate the no-till and cover crop adoption into categories and like into three categories, the cases where one is the lands with only no-till adopted, and the second is the land with only cover crops adopted, and the land adopted, both practices were adopted. Then we can see that the main increase in the adoption rate comes from the farms adopting both practices. And for the land only adopt those like one practice, they seem to like stick with the portion. And then we ask the perceived effectiveness. So this is the perceived effectiveness of no-till and cover crops in reducing the nitrogen in runoff into Iowa waterways. So we can see that over 60% of the landowners believe it is either somewhat effective or very effective for these practices in reducing the nutrients and pollutants in the waterways. And so it indicates a strong belief in the effectiveness of the practices. However, we can see that about a quarter of the landowners indicates either they don't know or they refuse to answer the question. So this also indicates a potential gap in the knowledge awareness of the value of these practices. So it also calls for the education efforts like on these practices for extension and outreach. So we also ask about the distribution of the decision-making authority between the landowners and the tenants regarding the conservation adoption and also the conservation programs enrollment. And we can see that tenants largely decide on the single season practices, while the owners are more involved in the permanent practices and also programs, which also normally last for a long time. So, and we can see that the joint decisions from both owners and tenants also incorporates a high share, like nearly half of them like decide these practices adoption like together. So it might indicate a high level of cooperation in conservation adoption decisions. And for the likelihood of increasing conservation practices under 3 different policies, we asked them based on 3 cases. The first one is estate tax waiver. It means the land enrolled in conservation practices are included or can be excluded from the value of the estate for estate tax purpose. And for cost share is the tax-free cost sharing available for conservation practices. Normally, you can get paid from the programs. And for the tax credits, landowners can receive tax credits for the implementation of conservation practices. And we can see like the darkest the color means they are very likely to adopt these to increase conservation adoption under this policy scenario. And we can see tax credits is the most welcome popular policy, while the estate tax is the least welcome one. And this can be explained by that the tax credits is more like has more audience, like compared to the estate tax, because estate tax only targets at the landowners with the estate ownerships type. And also it has a kind of less flexible time requirement because you have to receive this benefit until like the death, the established of your estate, while the tax credits is more like time flexible. And also cost share is the moderate welcome one because it can provide immediate financial incentives too, but it also requires some paperwork and restrictions, so which may be time and effort consuming for landowners. And for the willingness to adopt conservation practices depend on cost share payments. So it's like we ask how landowners' willingness to adopt these practices are dependent on the cost share payments. And we can see like over half of the landowners like indicate they are a little or not at all dependent on these cost share payments. So it might indicate that other than monetary incentives or these cost share payments, some other factors matter, like the stewardship for the environment protection, and also the other profit, like the other profit sources, like the improved yield from implementing the practices, and also the cost reduction of the fertilizer usage. That's also possible. And we also asked about their average cost share payment received, like for 2021 for cover crops. And we can see like a high proportion of landowners receiving low or no cost share. So like 41% say they receive none. And among those who receive the payments, they most receive from $10 to $30 per acre. And so this is also in line with the implication I made in the last slide that other factors can drive the cover crop adoption, because the payments seems not to be that important. It's important, but not that important. And we are also interested in landowners' familiarity with carbon credits programs. So we can see very few landowners indicate they have already signed up to participate or currently considering participating in the programs. And 20% of the acres owned by landowners who have heard of and are interested in the program, but 45% of acres owned by landowners who have heard of them but not interested in the program. And about 30% of them like have never heard of that. So it also suggests a potential need for the education on these conservation topics. So finally, these are the summarized takeaways. So cover crops are grown on 7% of the Iowa farmland, and no-till is used on 30% of farmland. And the main increase is from farmers adopting both practices. And landowners show a strong belief in the effectiveness of the no-till and cover crops in reducing water pollution. And landowners tend to make decisions on permanent practices and programs, while tenants tend to make decisions on temporary practices. The tax credits are the most popular incentive for the policy scenario for conservation adoption, and followed by cost share payments and estate tax reduction being the least favored. And a sizable proportion of Iowa landowners do not view cost share payments as the main driver for the conservation adoption. And then 2% of Iowa landowners have already participated in the carbon credits programs, and another 3% are considering, but there's still a large amount of them never heard of this. So that's any questions?
Okay, thank you. So we do have about 8 minutes for questions. Are there any questions from the audience in the room?
Yeah, I might have missed it, but how do you pick who you're going to survey? So there's about 700 surveyed?
Yeah, it's about so let me show you. Yeah, it's like 788 surveys in total. Is that we randomly pick, we have some specific sites that from 1988. And so we just choose the parcels, but randomly choose the 40-acre parcels from those sites. And yeah, and we asked the owners, because in one parcel there might be multiple owners. So we asked the owners like as much as we can to collect these answers.
Pretty good return, 45%.
Yeah. Maybe because,
Oh,
sorry. Maybe because it's a long-term project, so it's like every 5 years they're kind of familiar with this project, or they are willing to like do this for a long time.
Yeah, sure.
Yeah.
Would you mind going to the table you had where it had the percent of, I think it was decision making that was made by the tenant and landowner together? So that seems like a pretty high percent, higher than I would have expected. Did you look into maybe kind of relationship, like familial friend relationship there might be between the owner and tenant that were making the decisions together?
Oh yeah, that's a good point. We asked them if your tenant is your friend or neighbor or relative or something. Yeah, well, I can do that. I haven't done that, but yeah, good catch. Thanks.
All right, are there any questions from anyone online?
That's a question.
Yeah, I'll just ask if you have any plans for next steps then to build on this or to answer questions coming out of this.
Oh, so yeah, so I'm working on one chapter of my dissertation, which is so I mentioned here, I'm working on like the impact of the shifts in ownership structure on the adoptions of no-till and cover crops. Yeah, so the reason I'm interested in that is because the ownership structure, like it shifts from the family-based, which means the sole owner or joint tenancy or tenancy in common, this kind of types, to the trust or corporations or LLC, these types, like across years. So this shift, because like we call the trust and corporation and LLC, we ascribe them to the institutional like ownership, like versus the family-based ownership. So we think the institutional ownership may paired with more professionals like with better management skills, and also landowners like put their land into this kind of ownership may have a like long-term investment or like long-term investment goal for their future generations for land sustainability. So that's why we're thinking like if this can have some effect on the conservation adoption, but there are also some factors entangled, like the operating landowners versus non-operating landowners. Like they can be entangled. So we want to like separate those factors and like research on like the isolated effect of each factor on this adoption rate. Yeah. Thank you.
I was actually just looking at your report on this today for something I'm working on. So I saw that most landowners say that they had the land for some sort of financial gain, either long-term investment or current income. But they have very little interest in sort of the financial components of conservation practices, like being paid or cost share for conservation practices. Can you just talk a little bit about like why you, those seem sort of opposed to each other?
Yes. So one idea is that maybe they care about like different profitability source. It's like they do not really care about the payment, like the cost share payment, this source, but they care more about like the yield production benefits and also like the cost reduction, like this kind of profitability source. That's what I'm thinking about.
Okay. Yeah.
All right, well, I want to thank both of our speakers. We have a mug for our presenter, and Lindsey will be mailing you one of our INRC mugs. And we're going to do a drawing for the people who are in our audience today for a coffee mug. Jen Merriman.
Oh, yeah.
So once again, thank you all for attending. Our next seminar is going to be in 1 month, and it's also going to be the same format, graduate student and a recent graduate. Thank you.
I think everybody else in here has.
I'm good. I'm good.
Hey, thank you so much, Lindsey.
Yeah, thank you.
Thanks.